Good morning, Clint ISD. We are out here at Franklin CS Elementary School getting ready for our StratoStar balloon launch. And Mr. Swanson, talk us through a little bit what's going on here.
Hey, good morning, everybody. It is a great day to be in Clint ISD. We are here connecting up our payload boxes, and we're going to get ready to fill our balloon here in just a few moments. I don't know if you can see down here. This is our SATCOM box, the one that's going to be sending back all of our data back to the website so you can track and follow along. Then we have our box, our payload box, that has experiments in it. And on this payload box, we have stickers. Then we have a third box, our camera box, that will be taking all the pictures. We have video. We have some still photos going on. So you'll be able to look up, down, and sideways as soon as we get the camera back. So in just a few moments, again, like I said, we're attaching the harness onto this last payload box. We're going to connect it. Then we're going to start filling the balloon. And hopefully for an on-time lunchtime at right about 9 o'clock. So, kind of interesting part. We have 3 experiments inside the container. We have a mini Coke can. It's 7.5 ounces of Coke in a regular can. And if you don't know, the temperature change will probably drop to around minus 30, minus 40 degrees as it rises up through the atmosphere, which is pretty cold. So the question is, will the can freeze and bust the can, or will the can get all the way up into the upper atmosphere, close to 100,000 feet, where the pressure is almost zero, not zero, but very close to zero, and will it burst just because of the change of pressure? I don't know. I mean, that's part of science, trying to figure out what happens and why. So anyway, we have that experiment going on. Then we have we have some seeds in there, actually pinto beans. And so we have some here on the ground and some in the container. And so when those things come back, some of the schools are going to get a couple to actually try and grow. And I'm going to be growing them as well and posting pictures as they grow. I'm kind of curious, will the beans grow differently, the ones here on Earth, as opposed to the one in the upper atmosphere? So we have that little piece going on. Then we have some small soda, or small little vials that have a little bit of soda in it. Some have Coke in them, some have orange soda in them, and some have Sprite in them. We were just kind of curious. Each little vial has about 1 milliliter of the liquid in there, which is a really small amount in the vials, and we're really kind of curious what will happen with that soda. Will it treat all 3 the same, or is it going to be different? Time will tell. So let me connect up this payload box, and let me hand this over to my colleague.
Thank you, Mr. Swanson, for giving us a rundown on that. I'd also like to introduce our science coordinator, elementary science coordinator, Christina Castaños, who's packing these payloads. Say good morning, Ms. Castaños.
Hi, good morning, everybody.
And if you have questions, guys, feel free to shoot your questions into the chat on YouTube. We'll take your questions and we'll address them to the coordinators here as they prepare for this launch. So we do have the wind picking up, and so we are trying to work our best to get this launch off on time before it gets too windy today. And so let's take a poll for you guys who are listening on the call. Well, part of the reason why we weren't able to launch yesterday was because the wind shifted yesterday, and it was going to take the balloon to Mexico, and so we wouldn't be able to retrieve the balloon. And so let's take your guesses, guys. If you want to put in the chat, where do you think the payload packages will land after the balloon bursts? So give us your answers in the chat. If you have any questions, you can also give us your questions in the chat. And it looks like we're almost ready to begin filling the balloon with gas. And let's take another guess. What kind of gas do you think the balloon is filled with? Put your answers in the chat. And no Googling it. Just kidding. You can Google it if you want to. so what Mr. Swanson is doing right now is he's attaching a parachute to those payload boxes. And so how this is designed to work is the balloon's going to be filled with gas, and it's going to lift into the sky and head all the way to the stratosphere. Once it reaches a certain altitude, that balloon is going to burst. And so that's always a good question we have for you guys too, is how many feet in the sky or in the air, in the atmosphere or stratosphere do you think the balloon will burst? So you think it's 10,000, 50,000, 100,000, or more or less? Let's hear your guesses in the chat. I see some excitement here in the chat. I see first graders at WDS. Shout out to WDS watching. I see some other schools into the chat here. And it looks like we're about ready. So I think it's almost gas time now. And so we're going to now begin filling the payload with gas. He's going to need your help to hold the balloon down. And I guess I get to do the honors of turning on the gas here. So it looks like we're just about ready, guys, to start filling this balloon. And so what we're doing here is we're preparing a tarp to cover the balloon to keep it down on the ground. This balloon's going to have a lot of lift. And that's another question that we like to ask students and see who knows the answer. How do you measure lift? Bill, what's the measurement for that? Is it pounds per feet or?
Yeah, we typically measure that in pounds.
All right, so we measure the payload package weight in pounds to see if the balloon will have enough gas to lift the payload and the package. And so we're going to turn on the gas now. Ready? Did you close your regulator? It's right here, main. And it is balloon time, guys. We are starting to fill this balloon. And usually it doesn't take too long to fill the balloon. And so you guys can see now, the balloon is getting filled with gas. Mic volume. And I'm seeing some chats here that we have volume kind of low on the stream here, so hopefully we can get that adjusted for you guys. Let me see what else we got here in the chat. Take more questions from y'all. I see WDS students watching. Yay! Alright, so we're getting a balloon filled with gas. It's filling quite fast now. And we're going to speed up the gas here. And again, so a couple of questions that we asked here in the chat today. Question one was, what altitude do you think the balloon will burst? What gas do you think the balloon is being filled with? And how much weight are the payloads? What's the weight of the payloads? A couple of questions we have for everybody. So far, so good? More? And we're getting quite close, guys. This balloon is filling really fast. I'm going to slow down the fill a little bit here.
Go forward.
There you go. And again, the purpose of the tarp is to keep this balloon from lifting off, guys. And so Mr. Swanson's going to give it a little check here. Give it more gas a little quicker. So we're filling up this balloon quite rapidly. And so the balloon is very delicate. It's fragile material, so we can't touch it with our hands. And that's why the team is using a tarp to keep the balloon down. How many of you guys have seen the movie Up? Hey, Mr. Gaming, that's a great guess. I think the altitude is like, does that say 100,000? Oh, it said 10,000. Great guess. Let's take your guesses, guys. What altitude do you think the balloon's going to burst at? Where do you think the payload's going to land after the balloon bursts in the sky? More? Yeah, so Mr. Swanson's advising me to give him a little more gas. It's all the way. 10. 9. 8. 7. And what I'm reading now is the gauge on the tank. And so the tank is emptying out all of its gas. We're at 5. It's going to be all of it.
Yeah, we're going to use all of it.
And so we're going to empty out this whole tank, guys. We're going to fill up the balloon with every little bit of gas that's in here. I'm not seeing any guesses in the chat, guys. What gas are we filling the balloon with? Anybody want to answer? Take a shot at it. Think of your science classes. Think of what you know about balloons and lift. And what gas do you think this giant balloon is being filled with? Still going. You want me to kill it? 8:59. Find the button. Getting pretty close to liftoff, guys. Really close to countdown time. So be ready to count down. And so Mr. Swanson's going to prepare the final tie-off here. Get that balloon sealed and shut now that it's full and gas, ready for liftoff. Hello, FME. I see FME in the chat. Helium. All right. Is that the correct answer, Mr. Swanson?
Helium is the correct answer. It is lighter than air gas, so it does float.
Excellent. Great gas. Helium. That was the correct answer. So next question we have for you guys is, where do you think the payload package is going to land? Let's take your guesses in the chat. Let us know where you think that payload package will land. Need more tie-offs? Yeah, Mr. Swanson's getting that balloon finally sealed shut, sealed tight. Give him a little hand here.
Yeah. Una más.
Put one more tie on here, guys. These zip ties don't really click, do they? Another one?
Yeah, you got me snared.
So we're going to cut off the excess of the ties here. We're almost ready, guys. We are almost ready. Turn it the other way. There you go. One of us? That's good. Alrighty, guys. I think we're ready for liftoff. I think we're ready for countdown. Make sure there's no obstructions in the way. We don't want to get someone's foot tied into that. Wind is stable, guys. Look at that balloon. Oh my gosh, that is amazing. And so can we get someone to grab these boxes here? There you go. James, can I get you to grab another one here? Yeah, balloon is ready. Payload box is ready. James, one more, James. Payload box is ready. And get ready, guys. It's almost showtime. Here we go. Ready for a countdown, Bill? So what they got to do, what they're being instructed to do, is just keep the box in their hand. They're not going to hold it because it's going to lift right out of their hand. The balloon's going to take it really fast. Ready?
All right, do we have,
Here we go. Let's get a countdown, guys. Let's get a countdown. Here we go. We're going to start from 10. Ready? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off! Woo! Look at that balloon go. That was quite a lift. Oh man, that balloon took off. It's going super fast in the skies, guys. That balloon is on its way to outer space. That's a great shot there. You can see the moon in the back. And for you science guys and gals, what kind of moon do we have out there today? It's a beautiful one, but what do we call that? What phase is that moon in? And the balloon is gone, guys. It is traveling fast and furious into the sky. And so we got just a little shot longer, guys, of this balloon in the sky. Hopefully you can see that. It's turning into a tiny little white dot. And so we're going to transition over to mission control in just a moment so we can get some feedback there on the data that's starting to come in from this balloon as we break down the launch site. And that, ladies and gentlemen, boys and girls, is StratoStar here with Clint ISD. We'll take a quick pause from the feed here as we transition over to mission control.
Good morning, everybody. Thank you for tuning in. Frank Macias here. This is Mr. Ryan. We're so proud to host the StratoStar launch. We're having to do things incredibly differently this year, totally different. So you can see that live video behind me. We did a live feed into our studio here so we could broadcast the launch. So a couple things we want to talk to you about. The balloon obviously is getting much higher in elevation, and we're waiting on a couple visitors will be in the studio here. We're going to get Michael Tapia, and we're going to try and get Mr. Cortez from Horizon High School. He's going to try and join us this morning along with some of his students. So that's what we're going to try and do. One thing we do want to point out, if we can switch the camera to the mission control screen, number 2. So one thing we want to point out for you, there is a live feed. I put the link in the chat for this live video for the mission control. Just to share what this is, our mission is StratoStar 0366 today, sponsored by Clint ISD, no school in particular. This is our entire district all participating. So we sent up those payloads with those experiments, and then what's happening on the StratoStar link that I had on the screen, it's supposed to be giving us a live feed. So unfortunately, we're not getting the data yet from StratoStar, from the data feed that goes to the satellite and then comes back to us. But as soon as data starts to feed on that site, we will be posting that screen. But again, I put the link there in the chat so you guys can keep an eye on that. And what it does is it tracks the location of the StratoStar, it tracks the elevation of the StratoStar, and we're at a certain point, we should be able to see when the StratoStar balloon pops. So at a particular elevation, we'll see how high it goes this time. Will it be 70,000 feet? Will it be 80,000 feet? 90? Will we break 100,000 feet in elevation before it finally bursts? We will find out. So again, if we can put up that mission control, we'll kind of keep an eye on that. So they're saying there is no data. And so like I said, it is getting higher up there. I'm not sure if that's still the actual live feed or just frozen, because as it gets higher and gets smaller, it's really hard to tell. But I want to give some special thanks out to Mr. William Wilson, our district tech, who's here in the studio with us, making sure all of our cameras are running, all of our feeds are running. That's why I keep looking over, because he's giving me a cue if mission control's up.
Get the data working.
All right, so the update is no data is connecting yet. There's something that the amazing Mr. Swanson has to do to connect that data. So we did lose the feed. So go ahead and go to number 3 on the switcher. Number 2, 3, there we go. So anyway, that's the link to our YouTube feed. And so I just want to explain again what's happening right now with the StratoStar. Mr. Swanson, who has the controls and the connection with the StratoStar company, is connecting that feed. And what they're checking right now is if the data is being transmitted 100% from the StratoStar balloon to the satellite communication, back to the StratoStar company, and then it can go into that website as a live feed. So we're waiting on that. We're waiting to see. Do we got anything yet? Can you switch it to 2? Let's see. Right now it's still showing no data. So once Mr. Swanson has that connected, you're going to be able to see. If you can see the links up on the top, there's a maps, graphs, and data. So on that data link, I don't know, Mr. Jimenez, if you could go over and click on the data on the screen. And right now it is not activated. So once it is active, you will be able to go back and forth between those tabs. So we just want to let you know about that. And then I am waiting for Mr. Tapia to come join us as well. We'll get our masks on. We'll be socially distanced, and we'll do some Q&A with Mr. Tapia. All right. So, switcher on. Is Mr. Ryan up? All right. So make sure the bottom one is on number 3. And the top one is on me. All right. So I'm filling in just for a little bit. I know we got Mr. Swanson on his way to our FME studio here in room 512. Mr. Tapia will be joining him. What we are going to definitely do is probe a little more on the payload information and the experiments that are launching at this moment. And my guess is if Mr. Swanson is on his way, then more than likely we should be getting that data feed really, really soon. So I'm going to go ahead and look on the feed here and see if we have any questions. Couple notes. I'm really excited about all the comments people have been making. A lot of cool comments, a lot of positive. So what we could do at this time is if you guys have any questions that we would pose to Mr. Tapia or to Mr. Swanson, so go ahead and start filling them in the chat. But right now I'm not seeing any questions, just some chatting going back and forth. So anyway, that was probably, in my experience, that was probably one of the quickest setups and definitely one of the quickest launches of the StratoStar. I personally have been involved with StratoStar launches now for the past at least 4 years. I have Mr. Jimenez here in the studio. He's come over from WD Surratt School, and you've been involved how many years, Mr. Jimenez?
About 3.
He's been involved about 3 years. We've sent up all kinds of experiments from jelly beans to eggs to mixtures and chocolate to see what would happen. One of the cool things, I don't know how well Mr. Swanson had been able to explain, one of the cool things is we have camera angles on the balloon. So we have one camera pointing up so that we will be able to see when the balloon bursts. And what it does is it takes photos in real time. It's taking photos as well as video. And that information then is downloaded. And what we always try to do here in Clint is piece together a slideshow, give you all access to those photos. My favorite part definitely is when the balloon bursts. At around, I haven't checked with Mr. Swanson on what the data was showing, but we've gotten, in my recollection, as high as 92,000 feet or higher, 95. So let's see how high we can get this balloon to go before it does finally burst. And the cameras not only are pointing up, so you can see it bursting, another cool thing that you're going to see is the cameras are also pointing down, so that there's video showing the launch from the perspective of the balloon, and then there are pictures in real time, quick snapshots, repetitive shots as the balloon elevates. So after the balloon bursts, what goes up must come down, correct? So the cameras are still rolling, and we hopefully will be able to provide that video as well of the balloon descending and landing. So it looks like our visitors are heading over here to the studio. And Mr. Swanson, would you mind? I'll mask up. Would you be comfortable on the camera? And I'll shift over. And we got some questions for you.
Can we pull up the data stream?
Yes.
We got it, but we got nothing, sir.
Right now, Mr. Swanson's checking on that data.
I told Michael that we don't have any data coming from you.
And that's one of our key situations we got to take care of. Make sure that data feed is coming from the StratoStar and can be fed. Wow, I'm getting an attendance and participation. We have RSE going on. We've got Surratt that have joined us. So we got our, any other elementaries? Definitely FME. I know we got our friends at FME and Horizon High School.
See if they can check in, sir. I don't have anything anymore. So see if they can.
All right. If you are watching us live, we want to know that you're out there. So make sure that you are letting us know your school so we can give a shout out to your campus for participation.
You just refreshed? Yeah. This is not good? Yeah.
All right. So right now, you might have heard Mr. Swanson in the background. Data is not yet being received. So I'm going to do a real quick break while we're checking on this.
He's trying to get out of the microphone. All right, sir.
And I'm going to see what Mr. Swanson has for our update. We'll be right back, guys. All right. Am I on? I want to check my volume. You can hear me on the mic. This is Mr. Ryan behind the camera at this point. And I got a gentleman here checking data. Could you introduce yourself, young man?
Oh, I am sorry. Hey, my name is Bill Swanson. It is good to be online with everybody who's following along out there on this live broadcast. The balloon is up in the air. Woo! Yeah! So that's pretty exciting. And so we had a very, very smooth launch. We have a small technical difficulty with our data stream coming in. I'm on it. It is, I just got a track. It's over 8,000 feet and at 1,300 feet per minute. So yeah, if you can see the screen, you get a sense about what is taking place. So data should start appearing on the screen as time goes on. So that is the good news. So data is slowly coming in. We are super excited about this particular launch. I'm just going to tell you, some of the stuff that we put in the launch package this time is kind of similar to what we had before. Like, we put in a mini Coke can. I wish I had one to show you. I left mine out in the truck. But it is one of those really small Coke cans. And we put that Coke can in there for a particular reason. One, it is only 7.5 ounces of soda, so it's a really, really small Coke can. But if you ever notice when you open a Coke can that they're pressurized. And a pressurized Coke can, as soon as you open it, it goes, you know, and then all the gas comes out. Even if you shake it, it comes out really, really fast. So, but we're sending that up. And when, as it goes up through the atmosphere, several things happens. And one of those things that takes place is that it gets cold. It's called, for those who like the technical names, it's called, I believe it's called the adiabatic temperature drop. So for every 1,000 feet, it drops between 2 and 3 degrees in temperature. So it's over 8,000 feet now. 8 times 2 is 16, or 8 times 3 is 24. So it's probably about 20 degrees colder up there. Currently it's around 65. So up there it's already around 45 degrees Fahrenheit. So it's pretty cool. Well, this balloon's going to reach 100,000 feet, or just under 100,000 feet. It's going up pretty high. So a lot of exciting things taking place in terms of the balloon. So as the balloon goes up, as it rises through the atmosphere, it is getting colder and colder and colder. In fact, when it reaches, I don't know, 30, 40,000 feet, it'll probably be almost at its coldest, and it'll probably be around a minus 30 or minus 40 degrees Fahrenheit. Super, super cold. What happens at 30 and 40,000 feet? Something interesting. We change from one layer of atmosphere to another. And if you've looked at the science, there's basically 5 layers of atmosphere. The atmosphere that we go through right here, where all weather takes place, does anybody know what that's called? I'm asking, here in the audience, anybody know what we call that? I think that's called maybe the mesosphere, where all weather takes place. And as soon as it transitions from the mesosphere to the stratosphere, something interesting happens. The temperature starts to go back up again. So as we're looking at the data, you'll see the temperature declining, 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 and then all of a sudden the temperatures start going back up again. That is the clue or the indicator that we've entered the stratosphere. Our balloon will not exit the stratosphere. The stratosphere is pretty thick piece of atmosphere. And when it gets to the top of the stratosphere, or near the top of the stratosphere, the temperature increases as it goes up in the stratosphere. But once it reaches near the top, right before the balloon pops, the pressure is almost zero. So when we talk about pressure, when you look on our data set says 780 millibars, or it says around, I think it's around 19, I'm trying to remember, 19 PSI. When we pull up that data set, I'll be for sure on that. But it'll go from like 19 to almost zero. That's a tremendous amount of difference because, believe it or not, we walk around in air all around us. So I don't know who's ever been on the bottom of a swimming pool before is swimming, and you feel all that pressure on your body from all the water on top of you. We have that same thing as we're walking around. We have all that pressure of air on top of us. But since we live in it, we don't think too much about it. If you notice, if you look at our data stream already, we're already at 33,000 feet. 33,000 feet. And do you mind switching to the temperature for me real quick? The temperature data point. And so, let's see, we have around 17.5 degrees Fahrenheit. So it is getting super, super cold up there at that altitude. Again, the temperature will keep decreasing. And I keep forgetting, let me go back to our experiment. We have our soda can, remember, 7.5 ounce soda can, and that soda can is right now 17.5 degrees. Will it be enough? Will it be enough to freeze that can and break it? I don't know. Or when it gets up to zero pressure, will the can burst at that high altitude? Again, I'm not 100% sure. But if the can survives, when we go retrieve it later today, I may be drinking a cold soda out in the desert. We'll have to wait and see.
Mr. Swanson, are you going to drink that soda this time?
Will I drink that soda? Oh, I will so drink that soda, or at least some of it. Anyway, so that is one of the experiments that we are sending up. If you notice, one other interesting part about the stratosphere is that when you enter the stratosphere, not only does the temperature start increasing, but something else happens. The stratosphere is a very, very calm piece of air. Not a whole lot happens up there. So I don't know if you all are familiar with the idea of something that they call a jet stream, but we have these super, super fast winds up in the air. And those are typically between 30 and 45,000 feet. So right before it gets in the stratosphere, typically you get to those super fast winds. So if I use this for an example, this water bottle, when it's going through those super fast winds, this is what's happening to our balloon. It is shaking all over the place. It is going out of control. It is blowing around so much. And then it all of a sudden gets in the stratosphere, and all of a sudden everything kind of smooths out as it rides up. So I was talking about the idea of pressure, and so we have all this pressure on us, but as we go up, the pressure decreases because there's less atmosphere as you go up. So there's fewer molecules of air up above. So if you have ever heard or read stories about people who climbed up to the top of a mountain, super high mountain like Mount Everest or any other mountain, you will notice that sometimes they have to have oxygen to breathe. It gets a little bit complicated up there because there's less atmosphere, less for you to breathe. Well, at 100,000 feet, there's very little atmosphere. So the pressure is almost zero. And because that pressure is almost zero, then, because that pressure is almost zero and the pressure on the can on the inside with the carbon dioxide inside is so great, I'm kind of wondering if it will burst. So we will tell, and so if you look at this chart below, you can tell what is happening in terms of the pressure. And it is already well below 3. And the balloon, again, is at 41,500 feet. So again, the balloon is flying up there in the air. And one other thing about the pressure piece, you saw how big the balloon was right now. And I'm just going to ask my colleague, hey, David, can you tell me very quickly how big, what was the diameter of that balloon, you think?
Diameter of that balloon, I would say, give or take 15 feet.
For the diameter?
For the diameter.
Okay, so, go ahead.
Yeah, for the diameter. How wrong am I, Mr. Swanson?
I was thinking maybe it was a little bit smaller than that, maybe 8 or 10 feet. But it was a pretty good sized balloon. But one thing I can tell you, remember the atmosphere gets smaller. So when it's down here on the ground, it has all that pressure on the balloon to make it that size. But as it goes up in the atmosphere, there's less pressure. So what do you think is going to happen to the balloon? It is going to get bigger and bigger and bigger. In fact, when it reaches the altitude where it pops, it will increase by 4 times the size, 4 times the size. So if it was 10 feet diameter, when it bursts, it is going to be 40 feet in diameter. It is an amazing thing to watch it burst. So when we, when we collect our balloon, we will see exactly how big it was and see what it looks like when that balloon bursts. So I'm kind of curious, can we switch back to the temperature data screen? And so when I'm looking at that particular screen now, if you notice, it is just under 45,000 feet. And if you notice that the temperature there looks like it is maybe about 3 degrees Fahrenheit, 3 degrees Fahrenheit. That is super, super cold. And at 45,000 feet, it won't be too long before we enter the stratosphere. So we'll see pretty quickly when that temperature starts reversing direction. Stay hydrated. So let's talk about something else that's kind of interesting. So we also have sensors on the balloon that tell us about humidity. And another kind of interesting thing, since there's not very much atmosphere in the stratosphere, the humidity portion should be extremely low. So that humidity should be right around very close to 0 would be my guess. Do you mind switching to the humidity screen for me? And so if you notice, as it went up in the atmosphere, the humidity increased, and that's what you would expect it to do. The humidity should increase as it's going up in the atmosphere. Because again, when it's going up, it's going through all those clouds and everything. It's also, as it rises and enters into the stratosphere, that humidity will start dropping. So it's not quite there yet. It looks like, can't quite read that number right there. It is around, I guess, around 8.5 or 9 right now at 45,000 feet. So it is amazing. We've already been in flight now for approximately 25 minutes. Been flying for about 25 minutes, and we are already over 45,000 feet. So I'm just going to say, if you haven't done it with your class yet, I highly, highly, highly recommend that you tell your teacher, hey, I want to guess when I think the balloon will pop. I'm just going to say, I've always been right. My guess is always right on the nose. So, I'm kind of curious. Oh, okay, someone's disagreeing with me. Okay. Okay, one time I was off by 1,000 feet and someone beat me. But, okay, so I'm going to call that a tie. So,
You're replacing right quick, sir, so you can catch your breath. Okay, I'm getting somebody in for you.
Okay, so, so anyway, I highly recommend that you pick I highly recommend that you pick an altitude where you think the balloon is going to burst. And please send it into the chat or into the question portion. I think the balloon will pop right around 98,373 feet. Anybody write that down?
Give it to me one more time, sir.
98,000. 743 feet. That's my new guess. That's when I think the balloon will pop. So we'll have to wait and see. And I have a second guess at a number 2. So please send in your numbers. We are going to swap out while I get a drink real quick. And we have another guest speaker dropping in.
When he steps up, go ahead. Okay. On camera. Ready?
Okay, yep.
Go.
Alrighty, Clint ISD students, we have another guest for you, or another facilitator of this balloon launch. I'd like to introduce Ms. Cristina Castaños, Elementary Science Coordinator. Woo!
Hey everybody, hope you're having fun, learning lots. So I'm Cristina Castaños, and I'm the Elementary Science Coordinator helping Mr. Swanson out with this unmanned weathered balloon launch. So hopefully you're learning a lot and you're keeping track. Now behind me you can see the website. We send your teachers a link to that website, so there has a lot of information. For example, the name of the project that went up is Cassiopeia. So if you're wondering, what is Cassiopeia? Who is Cassiopeia? So go ahead and read that. Your teacher should be able to link that for you to get a little more information about that, as well as some science information. So there's a page for elementary, and there's a page for middle school, high school that you could go to get a little more information about all the cool stuff that Mr. Swanson was talking about. So if you're wondering, how high is that stratosphere? Where are we right now compared to how high does an airplane go? Well, look at that webpage. We have a little picture for you, a graphic that kind of gives you a great idea of how high we're going and how high the balloon is headed to. Okay, so I can't wait to see all your predictions out there. Now, one of the things that I have to do, since the balloon's going so high in the atmosphere, I do have to call the FAA, the Federal Aviation Administration. Why do you think that I need to make phone calls to them? Can you kind of predict why you think they need to know what's up in the air? What do you all think? Well, if you see that graphic, you can see how high an airplane goes. So if that balloon is that high, what do you think might happen? So the FAA coordinates all the air traffic that happens up in the atmosphere. So that weather balloon is going to look like an unidentified flying object if they don't know what it really is. So we really need to get that information up to them. So that's part of my job, is calling them up and letting them know the altitude. So I just made a phone call right now when we were at 30,000 feet. And then I'll go ahead and call them again when we're at 60,000 feet. And then we'll further be calling them and letting them know, because we don't want them to kind of get stuck with an airplane. So they're controlling where the air traffic is going, and we don't want any kind of collisions happening. So that's what I'm doing, and I hope that you're enjoying and tracking along in that link that is right behind me, I can see. So hopefully you're there and you are guessing, looking at our map, at our Google's map, to see where we're going to be retrieving soon. Okay, so once that balloon pops, we're going to be out there trekking through field, through the desert, through maybe even mountains to go ahead and retrieve that balloon for you to get that data back and see what is going to happen to that Coca-Cola can. What was your prediction? And will those seeds grow? Was that going to affect those seeds when they get back to Earth here? What do you all think? Well, it looks to me that I need to make another phone call. So it was great talking to you guys. And I am going to step aside to make that phone call. It's very, very important. And we're going to switch it over to Mr. Tapia. Yeah?
Hit it. Thank you so much, Cristina Castaños, for covering all that information. Again, guys, this is all on a webpage. If you want to track the mission, go to Mission Control. There's also the instructional website that's got all the details about the launch. And so next, I'd like to bring another guest into the studio here. And so, ladies and gentlemen, please put your hands together for David Gasca, our math coordinator. He's going to talk to you about the mathematical aspects of this balloon launch. Ladies and gentlemen, Mr. Gasca.
Thank you very much for that warm welcome, Mr. Tapia. Okay, so first of all, I'm looking for some predictions as to when the balloon is going to burst in that chat, and I see a couple numbers. I'd like to see a few more guesses there. Mr. Swanson just
I'm
gave
on the
us
mic
his
as
prediction.
well. We got a prediction here from Ms. Jackson's class predicting the balloon will burst at around 105,000 feet.
Whoa, Mrs. Jackson's class, taking the over on Mr. Swanson's guess. Now, I want to remind you, Swanson said he's really accurate with his predictions, so you might want to take that into mind. Jackson, I want to say
Yeah,
it
it
was.
was Jackson. I have a Miss Barrios class. They predict the balloon will pop at 98,900 feet.
Oh,
Looking through the chat here. We got a lot of shout outs to teachers. You guys love your teachers. I'm looking for more data. Holland. This Holland's group. I think the balloon will pop at 99,750.
99,750. Okay.
All right. And I'm scrolling through. I don't necessarily see predictions, but I do have a good question from one of our elementary students. Is it possible that the balloon could crash into an airplane? Would you be able to answer that one?
Okay, well, to a certain degree, I might be able to answer that. That's why the two science coordinators are on the phone with the FAA, letting them know where our balloon is currently at, so that way planes can divert, hopefully, away from our small object. Now, obviously, it would not be a great thing if our balloon was popped by an airplane, because that's a pretty dangerous hazard, I would say. But I would say the chances of that happening are pretty slim, I would say.
There's a lot of guesses coming in now.
Okay, now we're getting guesses. Okay, sir, from Alcantar's class, Ms. Alcantar's from Surratt. They have several guesses, so different students
Whoa.
gave guesses.
Okay.
One is predicting at 93,000 93,596.
93,596.
Another student has predicted 56,789.
56,789.
And we've got two more from Ms. Alcantar's class. 94,678. And a lower elevation, 84,674. Do we want to put up the elevation chart? See where
That's
it's at
exactly
right now?
what I was about to say. Let's see if we can get an idea of where the balloon's at right now.
What were we looking for, sir?
Current altitude.
I'm trying to get out of the way.
There you go. That's got everything.
So if I'm reading this correctly, looks like our altitude is currently at 64,580 feet. So just off of the predictions, I see one that we can maybe exclude. Now I see 62,943. So I'm going to go on Mr. Swanson's educated guess here. It looks like he is about 2/3 of the way up there. So how long has our balloon been in flight right now? How much time has our balloon been in flight? So I'm looking for that information somewhere around here. 31 minutes, okay. If anybody in the chat wants to make a prediction as to what time maybe based on that, so about 2/3 of the way altitude-wide, according to Mr. Swanson's educated guess. So it means about 2/3 of the time has already expanded.
We have a few more predictions, sir.
A couple more predictions. All right, I like
Yes,
the
we
predictions. Keep them
have.
coming in, kids.
We have, let me make sure I'm not missing anybody. We got Abigail Torres, one of our Frank Macias Eagles. She
All
was
right.
predicting 50,000 feet, but we've passed it. The chart was not up. So Abigail, why don't you give it another shot? Since the chart wasn't up, you didn't realize it was already past that. Give it another guess. We have a prediction, by the way, so that I'm not skipping anybody. Ms. Holland's class is predicting that the StratoStar will land near Waco Tanks. It is headed towards that direction, towards the mountains.
Yes, it is.
We've got Ms. Palacios, student, has, and I think 56,934. So whoever that student is, give it another guess, because we've already gone beyond that. Priscilla Leon, I guess Ms. Leon, we have two predictions, 97,650, 96,391. Abigail's back on. She is now changing her prediction to 99,757. I think she added an extra digit by accident. All right, I'm going to jump down a little bit. We got so many predictions. Miss Parada's fifth graders at Frank Macias, they are predicting high, 99,000, 100,000, and one student is boldly predicting 150,000 feet in altitude. Woo. And then, let me continue here. A landing prediction in Pine Springs. Miss Ramos, fifth grade at CTW, is going really high in the stratosphere, 127,843.
Whoa.
That is their prediction.
What class was that?
That is Miss Ramos at CTW. And then a student at FME, is Jesus de la Cruz, is predicting 100,000 feet. There is the Estrada family that's logged in. They're predicting, I think we have some digits off, but they're predicting 97,540. Another 100,000 feet prediction. All right, somebody named Selena Gutierrez, says 120,450 feet. Must have meant some deep thinking.
So
All right,
she
she's from
thinks the-
Surratt.
Minutes.
We have an FME student, 100,000 feet, Miss Bianca. And then I'm going to scroll down a little bit. I got an entire class prediction. Ms. Ramirez class at Red Sands. Shout out to Red Sands. Again, they are the 98,750. They put it in the millions. I think they mean in the thousands. That's my prediction. And then we have Cesar Barraza Jr., FME, predicting 100,000 with 500 feet. I'm looking for times. You were asking a prediction on time, right?
On time, right, yes. I was kind of taking a look at Mr. Swanson's guess, and I was saying that they, give or take, it was a little bit over 2/3 of the altitude that he had predicted right now. Something that grabs my attention is the vertical rates per minute. If you guys see that on the graphic right now on the bottom right area, it looks like the balloon increases 1,400 feet per minute. Now, that's a pretty decent amount. Oh, it just changed right now. So now it's at 1,354 per minute. So if we think the balloon is going to be in the air for, say, 20 more minutes, that's another increase in about 27,000 feet. If it's in the balloon is in the air for another 20 minutes, it'll increase that much. Now, there are other factors that might contribute to the vertical rate increase. As Mr. Swanson was mentioning, when it hits breaks the stratosphere, if I'm not mistaken, pressure changes, there's not so much wind, so there's not going to be an elevation push or a depression push. But those are some numbers that are jumping out to my head.
We have some time, some predictions of when it might land back.
Okay, all right, what we got
We
there?
have 10:12 a.m. from Ryan Chavez.
So Ryan Chavez predicts that it's going to land in about 18 minutes.
We have Michelle Jackson, 10:30 prediction.
Oh, 10:30, huh?
And then more times. Ms. Parada's class at Frank Macias. They're predicting when it will burst. What time it will pop? At 10:30 it will burst. Another one wants to say 11:30.
Wow.
And one person wants us to wait until 1:46 in the afternoon for the balloon to burst. We got 3 predictions there. Thank you, Ms. Parada's class. Great job.
You guys will be hunting it out in the dark.
All right. So we're going to take a quick...
Question, Mr. Gasca, so what happens in the evening if you do have to wait till 5:30 when it's getting dark?
Well, I personally want to find out what's in those payloads, so I'm really curious to see if Mr. Swanson's prediction as to the Coke can will freeze, and I want to see him drink it too. I'm curious to know if there's going to be some kind of mutations to his maybe physical appearance, maybe like a Hulk-like kind of turnouts possibly, maybe some Spider-Man, maybe a combination of them, and I would be intrigued to see what happens to Mr. Swanson once he drinks that 7.5-ounce can of soda, as he boldly said he would.
I think Mr. Swanson would make a good Hulk.
He's got some Hulk in him for sure. Mr.
Swanson, if we go into the evening and it gets dark, are we going to continue to try and retrieve this tonight? Yeah.
We will have this balloon back tonight. We will have retrieval today, and we will be updating that on Twitter as well as, well, I don't know about online, but certainly on Twitter and hopefully on YouTube. So we'll see.
Actually, from what I understand, Mr. Ryan is going to get in on this, and he's going to actually try and give us a feed that I'm not sure if we're going to be able to go live, but we will at least give it post. Mr. Ryan, what do you think?
Well, it depends on my lovely T-Mobile cellular signal. So if I have good signal wherever the balloon lands, we will attempt to post live. It'll be on this Frank Macias channel since we have the access. And like Mr. Wilson had mentioned, if we cannot post live, we will definitely get video shots and we'll put that together. I'll put Mr. Venegas to work on our video side. But we'll get something definitely posted and we'll just continue to use this YouTube channel.
Perfect. Thank you, sir.
And we had a question about the soda. It is a question I'm going to throw back to the audience. Will the flavor of the soda change after it goes up into space?
Whoa.
Ooh, any predictions on there? How about in the chat, you guys? Throw a couple of predictions out there. Will the flavor of that soda in the can change? So regardless whether the can bursts, it's in the sealed payload, so the soda will be inside. the question would be, will the flavor of that soda change? So we have a little bit of a delay on the YouTube chat, so when we start to see those responses, we'll see what you guys all predict. What do you think, sir?
I personally do not think the flavor will change. Now, we also included small vials with 3 different types of soda. There is not just that 7-ounce can. There's also 2 vials of Sprite, 2 vials of Coke, and 2 vials of orange Fanta, if I'm not mistaken.
All right, reviewing the chat. Haven't gotten the predictions in yet. Like I said, there is a delay on the YouTube chat. Keeping an eye on it. Someone asked a question about a location, and we have the map up, and they realized, never mind, it's still in the desert area. So,
Can you speak in the mic for just a moment?
yes, you know what? We're going to put Mr. Swanson back on. Let's give us a quick second to transition. And Mr. Swanson will be
It doesn't
up.
matter. I can be here or there. I don't care. Can we be there? Okay, Ms. Swap out.
Hey, welcome back, everybody. So I just want to point out a couple things. If you're looking at the map that I'm hiding behind me, I would really want them to pull up the map that shows the temperature, or not the map, but the data that shows the temperature. And when you look at the temperature, what has happened? Notice that the temperature went from around 27, 28 degrees and dropped all the way down to -5. Remember what I told you before, what happens when the temperature starts increasing again? That means that we are in the stratosphere. So we have passed that point, and I'm looking at that. That's the time. Do we have one that shows the altitude instead of the time? See it right up at the top? No. See the one at the axis T where it says altitude and now temperature down below? And so if you notice, if you're looking at that, where did the temperature change? The temperature changed right around 55,000 feet. So, my God, we made a huge discovery. Yes. Yes, right around 55,000 feet is when we entered the stratosphere. Remember what else I mentioned about the stratosphere? That part, the humidity is really low. So let's see if that came true. Let's see what the humidity looks like now. Yeah, I'm keeping them busy over there.
Yes, sir. You got it.
And look what happened to the humidity. We started off around 8. Once it got up into that stratosphere, it dropped down to almost 0. And so, no humidity up at that altitude. Remember what else I mentioned? That there would not be much in terms of turbulence or wind. So let's click on the turbulence again. Do you mind clicking on the turbulence? And let's see if it's very busy up at that altitude. Okay, so maybe we're a little bit off on that turbulence piece. But it's really, really kind of exciting how things have changed in the stratosphere. And so, do you mind switching back one more time to temperature? And so, when we're looking at the temperature again, notice what we're well above. We're right around 25, 30 degrees. It is pretty warm up there. I will tell you, as it continues to go up, it will reach a point where the temperature will start dropping again. And then the temperature will increase again. And every time you have that temperature change, you're going through another layer of the atmosphere. So it is super, super exciting that we can tell by just looking at a graph. Do you mind going back to the maps real quick? And so if you notice and look at the map, I wonder about how high we are up there. So do you mind, yeah, let's see. What is our altitude? So over there on the, yeah, you mind getting our altitude?
Yeah, go back to data or graphs.
Yeah. So we are currently over 80,000 feet. In fact, our exact rate is, what would that be, Mr. Gaska? It is 86,663 feet. So I'm looking at the numbers, predictions on the wall, and I am only 12,000 feet from victory! Woo! 12,000! 12,000 feet for victory!
And the bell. And the bell.
Let's see if Mr. Swanson is right this time. I'm not so sure. There are some really, really good predictions up there. Hey, but before we talk any more about that, I just want to mention really quickly that we had other stuff in the balloon besides just the soda. We also had in there some seeds, some pinto beans. Yeah, we put some pinto beans. We put some pinto beans in the container, and they are open to the air up there. So I am really curious what's going to happen with the pinto beans. When those things get back down, we are going to plant them and see if they grow. Are they going to grow as well? Are they going to grow as well as the ones that we left here on Earth? And we call that a control. So we are controlling. So nothing's going to change in terms of those pinto beans. So we're going to see if one grows better than the other. In fact, maybe the ones that we sent up to almost 100,000 feet, maybe those things won't even grow. I don't know. We'll have to kind of wait and see. I will tell you what I think might happen is as it goes up, and since the air is so dry, it is probably pulling moisture out of that bean. So I'm not sure what's going to happen, but it's going to be curious to find out. So, so we will see with time exactly what is going to happen with our beans. Then we sent up one other thing that was kind of interesting piece. We sent up some small vials that had some different colored liquids in there. One was a clear liquid, one was an orange liquid, and one was a cola liquid. 1 milliliter in 3 separate vials.
You got pictures? You can talk to them.
Oh. So in fact, if you want to look at our payload box, this is our payload box on the ground before we launched. And so if you notice in there, can we go back to the other picture where we're looking more down into it? Oh, perfect. And so that is our payload box. And when you're looking at that payload box, you will see our Coke in there. Remember, that's the mini can. And we have that strapped in. Remember, that thing is going crazy. It goes up through the atmosphere. It's getting shaken up quite a bit. So we have it tied down in there. And if you notice up there towards the top, to the top right inside the box, those are our pinto beans. There's around 30 or 40 pinto beans in there. Thank you very much. Yep, you can see them in that little sachet bag. It's open to the air so the air can get at it. And then right below that, you will see that there are those small vials, and they're really small. And so those vials all have that liquid in it. Each one has 1 milliliter of liquid in it. And so I'm kind of curious what is going to happen with those vials, if anything. Are they going to rupture? Are they going to be frozen when we get out to find them? Time will tell based on our pressure and temperature changes as we go up in the atmosphere. But, and I will say as well, another kind of interesting piece that we did, besides sending up those 3 different experiments, is a lot of schools, a lot of students, teachers sent in patches, and we put those patches on our payload boxes when we sent them up. So if you look here in the pictures, you can see, and maybe you see your patch there. There's some from FME, and there's some from WDS. So there are some from just around the district, those different patches. So that's kind of a really cool thing. So just knowing that your patch went up to close to 100,000 feet. And so I'm really curious about what our altitude. Wait, go to that last picture there so we can see some more pictures real quick. Do I have another one? Yeah, see? You guys did an awesome job on those. I love the eagle with the antennas. Oh, awesome. So we're going to switch back real quick because I'm getting excited because we're getting really close to where it is going to pop. Oh my goodness, look at that. 93,399 feet. A little bit more?
5,000 more for you, sir.
Oh, 5,000 more for me. I'm going to tell you, I would be more than glad to be wrong if we got over 100,000 feet. We have never gotten over 100,000 feet. This may be the first time ever over 100,000 feet. We will wait and see. This is super, super exciting. I can't get over it. And it looks like we will maybe have to walk through a few mountains to go pick up our balloon. So we'll see, but it still has to come back through the atmosphere, which is going to blow it off track. So no worries there. We will get that balloon today. So in terms of that, I'm kind of curious what that temperature is at 94,000 feet. If you don't mind switching to the temperature real quick so we get a sense about that.
Which one, sir?
Temperature.
Okay, almost there. I'm gonna go grab it from the back.
And it looks like our temperature is even higher now. It is getting pretty warm as it is approaching 100,000 feet, much warmer than I expected. But again, we do not have much longer before that. I think that balloon is going to pop. And when that balloon pops, and I know Ms. Castanos walked you through that process, one of the things that we are required to do is get a hold of the FAA and to tell them about when that balloon passes back through airspace. Our balloon goes to 100,000 feet, which is 2 to 3 times higher than the average plane. Typically, when you're flying in a plane, you might hear the pilot get on and he'll say, oh, this is the pilot speaking. We are cruising at 38,000 feet. And typically they will tell you the temperature or something like that. Well, our balloon goes much, much higher than that. But we don't want our weather balloon to interfere with airplanes. So we contact the FAA on a regular basis to let them know exactly what's going on with our balloon and where it's at. But the height of our balloon right now, the FAA doesn't care because it's higher than the normal planes. Their typical plane won't fly much more than about 45,000 feet. So we're over almost twice that number already. So do you mind going back to our altitude? And so if you notice now, we are just under 96,000 feet.
97. Just went up.
Oh, 97,310. Oh my goodness. Oh my goodness. I have 1,500 more feet to victory. Woo! Anyway, so we are getting really close to when that balloon will pop. And we'll see if Mr. Swanson's going to be right or if this is going to be the one time when he gets beat. So I'm looking over here at the board and everybody's predictions, and there's a bunch of people getting crossed off. And it looks like my number is coming up next. So I'm getting a little bit nervous, but not that nervous because, well, I don't know, maybe a little nervous. We'll see. But anyway, so again, 97,310 feet. We'll have a new data stream coming up here pretty quick. And I'm wondering if it's going to show that the balloon popped.
98.6.
Oh, 98.6. Okay, it's time for you to pop, balloon. Pop.
Mr. Swanson, do you recall off the top more or less what the other ones were popping at on our previous flights?
Every single balloon that we've ever launched has popped between 94,000 and 99,000 feet. We've never had one that's gone over 100,000 feet. That's my dream. That is my dream, over 100,000 feet. So let's see what happens. I'm hoping that this is the time that it will reach 100,000 feet. So we'll see. But I'm really nervous about that data set, that next data set that comes in. 98.6, ooh, I don't know. My guess, again, is 98,743. So,
That's 81. 98.681.
yeah, so it needs to pop now if Mr. Swanson's going to be right. By the way, Mr. Gosko, what was your guess? I'm kind of curious. Do you have a guess up there on the board?
Well, it'd be a little cheating right now, right?
Oh, he never made a guess. Okay, I see how
Okay,
that
now
is.
he can win.
Yeah, now he can win. By the way, I'm kind of curious. Is there any guesses, any questions on our screen right now? Or are we good to go?
Do we have questions? Do we have any questions or anything on the fees?
I'm telling you, I am so nervous. I keep looking at the screen. Ooh.
Nothing?
So no questions at the moment. So that's good. I guess we must be doing a really good job explaining everything. Oh! Guess what, everybody? Guess what? Oh my God! Oh my God! Woo! You'll never guess what happened. You will never guess what happened. The balloon popped. It is now dropping. Oh my goodness. Could Mr. Swanson actually be right again? Huh. I don't know. It is going to be super, super close, my guess. And so at the moment, it looks, yeah, can you put your cursor right on the edge of it? On that dot?
99,888.
Oh, 99,888. It looks like
112 short of 100,000.
someone wrote 99,750. What's the name on that one?
Holland.
From Miss Holland's class.
So from Miss Holland's class, looks like she was more accurate than me. Woo! Miss Holland's class! Yeah, you guys are awesome! You beat the guy who's been doing it a while. That's hard for me to believe. You know, I don't know, but more power to you. I'm sorry?
It's been the highest.
Yeah, this is the highest one we have ever had. Ever had. 99,888. That is amazing. In fact, when we get the balloon back and we get the data packets in, it may have gone slightly higher than that. So let me explain that process to you really quick. Because as the balloon goes up, we get feed from the satellite about I think it's every minute or 2 minutes. So the balloon could have still been rising for a little bit at that last point. So it may have even crossed the 100,000 mark barrier. So yeah, we'll have to wait and see. That would make me super happy. But here's what I'm going to say. Miss Holland, you were on it. Your class, nice guess. And there's a bunch of others that are pretty close, but that was most excellent guess. So, do we have an update on our altitude? Again, I have to keep close eye on that altitude. When it reaches right around 50,000 feet, I have to call the FAA. And so, yeah, so it's at 92, and I will tell you, it drops rather rapidly.
When you're ready, you can cut the feed. You just close out, and we'll go off of your cue. When you're ready.
Oh, okay.
You
Awesome.
can run as long as you want.
Oh, okay. So they're telling me I can talk all I want.
Yes, sir.
Yeah. So, yeah. Who knows what we're going to be talking
This
about
is
today?
all yours, sir.
So,
You can do whatever you want.
So there is one last thing I want to talk about. And in all seriousness, the project Cassiopeia. And so you may be asking yourself, how did you come up with that name? Well, very curious about Cassiopeia. Cassiopeia is a constellation in our night sky, but it's all based on Greek mythology. So I don't know how many of you have read or listened or know anything about Greek mythology, or maybe even watching movies. Oh, awesome. So yeah, you can even see that constellation down there. And a lot of people call it the lazy W. So I always look at that in the night sky. For me, it's a lazy W, but we call it Cassiopeia. In fact, on our webpage, there is a piece there where you can listen to the story. Probably be a little bit better than mine. I'm going to give you the quick and dirty version. But Cassiopeia was a queen, and she was a very beautiful woman. And she said that she was so beautiful, the most beautiful thing in the world, and Poseidon, the sea god, got upset with her. And he got so upset with her that he was going to release the Kraken. And the Kraken was a monster or a beast that lived in the ocean, and he was going to come up and punish Cassiopeia. And Cassiopeia who did not want to be punished, decided what she would do is she took her daughter's name was Andromeda, and put her out there so that the Kraken would get her as opposed to Cassiopeia. Well, if you know the story, Perseus was the hero. Perseus had the head of Medusa.
66,000.
Perseus had the head of Medusa, which, remember, has snakes on it. He showed it to the Kraken. The Kraken died, unfortunately. Kraken's kind of a cool thing. But anyway, so the Kraken was gotten rid of. Perseus was the hero. And eventually what happened then is they put Cassiopeia in the sky. And what they say is that lazy W that you see in the screen, they made that her throne. So they put her in the stars for punishment. And the Cassiopeia is in our northern sky, and in that northern sky, all it does is ever rotates. It's always there, 365 days a year, and rotates. So part of the time, Cassiopeia is sitting on her throne straight up, and part of the time, she is hanging upside down. So that is her punishment. That is her punishment for angering Poseidon. So kind of a great story. I hope you find some time to listen or read the story. Anyway, as for us in the Eagle News Network,
62851.
in the Eagle News Network, I just want to thank everybody for being a part of this process, this live link process, and following along with our weather balloon. You'll certainly still be able to follow the tracking. We hope to be on again after a while later today when we go out and collect the balloon. We will certainly let you know. But I'm personally going to sign off. Thank you again for being a part of this. And congratulations, Miss Holland's class, for that great guess of altitude.
Eagle News guys.
All right, we're gonna swap here real quick. We just want to give a thank you. I got my partner here. I'm here. I'm gonna have to crouching dragon.
A little bit forward.
Hidden tech coach. There he is. Thank you guys. We want to say thank you very much for joining us, participating today. Thank you, Clint ISD, for using our ENN facilities. And a very happy birthday to this young man right here. It's his birthday. Woo! See you, everyone. And like I shared earlier, I will be helping retrieve the balloon. So I will get that video. I'll get the shots. We'll try to do a live link. We'll see how we can make that work. But you guys have a good day, and thanks to everybody for tuning in. Bye-bye.